We're solving problem 16 from the 2021 F equals ma. A particle begins at the point x equals 0 and moves along the x-axis with initial rightward velocity v0. Later, the particle reaches the point x equals L. The velocity is a function of position during the time interval shown below. Consider the three following statements. 1. The particle instantaneously stops at x equals L. 2. The particle is uniformly accelerated. And 3. The particle could be performing simple harmonic motions. Which of these statements are true? So for this problem, let's just analyze what this is. Let's just first see. If this particle is performing simple harmonic motion, that would mean that it's changing direction, like moving back and forth. And since this is a case of x position, it's positioning of position due to the x-axis. We see it's not changing direction, it's only going one way or another with the velocity decreasing. So we know that number 3 isn't true, so any answer with number 3 in it is not true, and the only one that has that in it is D. Let's look at number 2. The particle is uniformly accelerated. Well, you would think it's uniformly accelerated because it's deaccelerating at a constant pace, or at least it looks like on the exam it's drawn as a straight line. However, the function velocity of x is not the same as velocity of time. Velocity, if this graph was due to time decreasing over a constant period of time, that would be true of this graph, but since it's velocity due to x, it wouldn't really be uniformly accelerated because it'd be decreasing at an exponential pace. So it would be decreasing exponentially rather than in a linear graph. So we know that number 2 is incorrect. Now we can rule out all of these. Now, let's see number 1, if that's correct. The particle instantly stops at x equals L. Well, this looks correct because it's due to position that it instantly stops. It's not like time or anything. So when it meets this point at x equals L, it just instantly stops. So that would lead us to our answer being A, right? Well, actually for this problem, there are 2 solutions. Since the graph of, since we just disproved number 2, how the particle is not uniformly accelerated, it's actually exponentially decreasing, there's a limit to where it goes and it's just infinitely close to that number, that point x equals L, so it's never touching. So another valid answer for this test would be E, none of the above. So for this problem, there are actually 2 solutions, and that makes it really weird.